Okay, this is an algebra lesson that we can find on page 310. In this lesson, we are learning about perpendicular lines and the slopes of perpendicular lines. So, determining slopes of perpendicular lines is the name of it. And when we were last together learning, which has been a few days, so I want to refresh your memory, we learned that the slopes of perpendicular lines are negative reciprocals. So I just want to refresh your memory on that. They are negative reciprocals. Also, sometimes when I write perpendicular, I'm going to abbreviate it with the geometric notation. And when you see this, that means perpendicular. So sometimes instead of writing out the whole word perpendicular, or if you don't want to write out the whole word, that's the symbol. Okay. So you can use that. I'm going to change the tip of my pen because I don't like the one I'm using right now. So hang on just a second. Okay, so consider the graph shown. Use a straight edge to extend JK to create line P. So let's do that first. Let me get a ruler, or I'll just use a line. And then we're going to extend GH, which is this one. Let me undo that. This looks all a mess, so let me just redo this with an actual ruler. Sorry about my dogs. Okay, they're playing. Okay, so there's that one. Why is it a dotted line? I don't know. And here's this one. Okay, this is good. Great. Oh my lord, the dog. Okay, sorry guys, we're together. Oh, that's why. Oh, okay. Here, much better. And here, there's our two lines that we need to extend. Okay, so we extended GK to create line P. We extended GH to create line Q and extend FJ to create line R. And we gotta do it again. This is gonna be R. No, Jack. My dog wants to look like here. And then we're going to extend KL to create line S. Okay. So now that we have those done, let's see what it says to do next. Okay, consider the three horizontal lines that we drew for question one. For any horizontal line, if x increases by 1 unit, how many units does y change? So for any horizontal line, if x increases by 1 unit, how does the y change? Well, it doesn't, does it? If x increases by 1 unit and just moves over, y stays the same. Okay, so now, sorry for the messiness. Describe the slope of any horizontal line. Explain your reasoning. So do you remember we're not going a rise over run, we're not doing anything like that. We're just going so let's say let's just name some points. X1, Y1, X2, Y2. So let's just say that we have 4, 4. And then let's say we have 5, 4. So Y1 minus y2 over x1 minus x2. 0 over 1. So anything over 0, I mean 0 over anything. Anything over 0 is undefined, but 0 over anything is 0. So does describe the slope of a horizontal line? The slope of a horizontal line is 0. Explain your reasoning. And we just did this way. Okay. Consider the vertical line we drew in question 1. Suppose that y increases by 1 unit. How many units does x change? X does not change. If y increases, oh, Jack, I'm sorry. Okay, x does not change if y increases by 1 on the vertical line. So what is the slope of any vertical line? Well, we already talked about it a little bit right there. So if, let's just do this again, x1, y1. If x is 4 and y is 4 and x is 2, sorry, x2 is 4 and y2 is 5, then we would say 5 minus 4 over 4 minus 4. That gives me 1 over 0, and that is undefined. So we need to memorize that the slope of a vertical line is undefined and the slope of a horizontal line is 0. Okay, so we've gone over that several times this year so far. So now we've got that memorized and we kind of know exactly what that means and what it's talking about. Okay, so let's move on to the next page. Determine whether each of the given statements is always, sometimes, or never true. All vertical lines are parallel. So if a line is vertical, it's going to be parallel. So that is going to be always. All horizontal lines are parallel, always. Because if they're not horizontally perfect, they're not going to be horizontal. If they're perfectly horizontal, perfectly vertical, they are going to always be parallel. Describe the relationship between any vertical line and any horizontal line. So if we have a vertical line, I did the horizontal first, sorry. But if we had a horizontal line and an exact vertical line, like we do on the coordinate plane when we're having like just a blank coordinate plane, then those lines will be perpendicular. And I'll spell it out this time. They will, sorry, my dog is playing with me and I can't write and do this at the same time. They will be perpendicular. Okay. Write an equation for a horizontal line and an equation for a vertical line that pass through the point 2, -1. So we'll say the point is right there. So what is going to be the equation for the horizontal line that passes through that? That is just going to be y is equal to -1 because no matter where we go, we are at y is equal to -1. So what about the x? If we have the vertical line, then no matter where we go on that vertical line, we are at point 2. So x is equal to 2. So write an equation for a line that is perpendicular to the line given by x equals 5 and passes through the point 1, 0. So if it is going to be 0, x equals 5. Let me see. Write an equation for a line that is perpendicular to the line. What did I put on here? Let's look. I can't remember what I said. Okay, if it is perpendicular, I'm just going to stop right here. I'll upload this and we'll pick it up from right here when I can tend to my dog.